Good morning students. Today we are going to handle about the Karnaugh Map, that is also termed as K-Map. This Karnaugh Map is a systematic approach used for simplifying the Boolean expressions or logic functions. Even you can simplify the Boolean expression using Boolean algebra, the De Morgan's law, but that will take a time consuming one. And this K-map is a diagram made up of squares with each square representing the minterm, one minterm of the function. So if you take n variables on a K-map, then we will be having 2 power n numbers of squares. It can be drawn directly from either minterm, that is sum of products, also termed as SOP, or max term, it is product of sums, it is termed as POS, Boolean expressions. K-maps can be used for expression with 2, 3, 4 and 5 variables. The number of squares in the K-map will be equal to the number of combinations, as well as if we are having 2 variables, then we will be using 4 squares. It will be in the form of 2 power n. If you are having 3 variables, 2 power 3, it is nothing but 8 squares. And if you are having 4 variables, 2 power 4, that is nothing but 16 squares. This K-map can also be described as a special arrangement of a truth table. In the truth table, you will be having rows and columns. Instead, here you will be having the squares with each square representing the input variable of the minterm. The types of K-map, we are having 2 variable K-map, 3 variable K-map, 4 variable K-map and 5 variable K-map. And this is the representation of the 2 variable map, in that only A and B are the 2 variables. So you know that 0 and 1 is the variable, is the binary pattern for A and B. So you will be having the minterms as M0, M1, M2, M3. And the 3 variable map, you will be having A, B, C. So totally 8 squares. So it is represented as, in this case, whenever you are having BC, 2 variables, you have to check 0, 0, 0, 1. You will not be getting 1, 0. It will be 1, 1. Then it is 1, 0. So what will happen means, your minterms will become initially M0. This is 0, 0, 1 is M1. But this is nothing but M3 since it is 0, 1, 1. And next it is 0, 1, 0, that is nothing but M2. Similarly, if we take this cell, this is M4, M5. Instead of M6, we are having 1, 1, 1. So it will become M7. So you will be getting M7, then it is M6. So it is a 3 variable map. So coming to the 4 variable map, we will be having 2 variables vertically and 2 variables horizontally. So you will be having 0, 0, 0, 1, 1, 1, 1, 0. Similarly here also 0, 0, 0, 1, 1, 1, 1, 0. So the same thing you have to implement here also, M0, M1, M3, M2, and here M4, M5, it will not M6, M7 and then M6. Similarly for this case, you can able to see it is 1, 1 and it is 0, 0. So, and you know that we will be having the combination for 4 cells as 8, 4, 2, 1. That is, this is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So, if you are having 1, 1, 0, 0, you will be having, that is M12. Similarly, 1101 is M13. 1111 is nothing but M15. And 1110 is M14. Similarly, 1, 1, 0, 0, 0. So what will be getting means 1 0 0 is nothing but 8. So this will become M8, M9, and again since it is 1 0 1 1, it will become M11, and the last term is 1 0 1 0. It is nothing but M10. So this is the way you are forming the map, K map. So in the 5 variable K map, we will be implementing using two 4 variable maps. So in that we are representing A0 for one map and AS1 for another map. With AS0, the remaining variables if you are taking, it will be BC and DE. So 0, 0, 0, 1, 1, 1, 1, 0. Here also the same thing. So here M0, 1, 3, 2. The same way that we have find for the 4 variable map, here also you will be using. And what will happen means, you know that here it is 0 to 15 over. So the next variable will be 16, 17, and it is instead of 18, you know that since it is 19, it will become 18. Similarly 20, 21, and it is 23, 22, and here 24 will be coming here since 10 is here. 24, 25, 27 and 26. The remaining term is 28, 29, 31, 30. So from 0 to 31, totally you are having 32 squares, 2 power 5. That is your number of squares since it is a 5 variable K map. Next one is rules for grouping. It is adjacent. How do you group the, since we have formed the K map. Now how to form the grouping. After finding the K map, what you have to do? You have to fill one wherever the min terms are given. So the adjacent ones can be grouped and all the corner or the adjacent corner can be grouped, and you can group only at the right angles. The diagonal groups are not allowed. Okay, and already grouped ones can also be used, and don't care condition can also be utilized. And in K map, grouping of 2 cells are termed as pair, grouping 4 cells are termed as square, grouping of 8 cells is termed as octet. So whenever we are grouping, we have to start from the maximal grouping, that is octet. If there is no octet, then we have to go for quad. Then we have to go for pair. If suppose anything is not there, then we can go for the single. And for example, this is the octet grouping. Can you able to see? You are having 8 ones. So grouping of 8 cells. So this is termed as octet grouping horizontally, and this is vertically. You are having one more octet grouping. These are the examples for octet grouping. Some more examples. So you can also group like this. Can you able to follow? So this ones, 4 ones and these ones, these two will form a octet grouping. Similarly, vertically, these 4 ones and these 4 ones in the cells will form the octet grouping. And coming to the K-map simplification for 2 variables. So we have already seen that this K-map is used only to simplification of the expression. So here we are having 2 variables x, y, and in these 2 variables, you know that simple addition 0, 0, 0, 1, 1, 0, 1, 1. So what you are having means you are having the truth table. This is your truth table. And for if you take the function for this, the function is for 1, 1, 1 only we will be taking. So it is x bar y, x, y bar plus xy. This is your function. For this, what we are going to do means we have to implement in the K map. In the K map, you know that first 0, 0 is 0, 0, 1 is 1, all the terms are 1. So how will you group this one? We will be grouping like this. So this is one cell forming one grouping, and this is another grouping. So we have to find the common terms for this one. For this group, if you take the common term, it is nothing but x. And similarly for this grouping, if you take the common term, it is y. So what will be your function? Function is nothing but your function is equal to x into y. That's all. So can you able to follow? So in this way, you will be following x is one function and y is another group. So your function is x plus y. So from the expression given, you can form the K-map and you can simplify the two variable expression. Next, how to simplify the three variables. So they have given the variables like this. So x, y, z. You know, for this is x bar, y bar is z, so it is 1. It is x bar, y is z, so it is 1. And this one is x, y bar is z, and this one is x, y, z. So only 4 ones are there. So this type of grouping, 4 cells, is termed as quad. Okay. So if you take the common terms for all those terms, there is no common term for all the ones. But here if you take the common terms, the common term is nothing but z. So the common term is z. So f of x will be equal to z. So this is the way to simplify the three variables. So this is an example for simplification of three variables. Thank you, students.